And with my colleague Alberto Palotta, we are organizing this fantastic seminar where we have Alessio Treglia, the Vice President of the for Engineering for Ignite, a former Tendermint, and Denis Fadeev, who kindly will explain to us everything we need to know about proof of stake and show us a demo of Starport, which will allow us to create apps. Is that right? Blockchains. I mean, just it's up to you. We all.
That's
Yes.
correct.
Thank you.
I will introduce the various
Okay.
subjects and also introduce
Absolutely.
and Starport CLI, and then I will leave the floor with Dennis. So if
Okay.
you are
Brilliant.
good, we can start.
Yeah. Thank you.
So first and foremost, thank you, Silvia. Thank you, Alberto, for having us here today. We're very happy to illustrate, in a way, share the journey that we went through in the process of creating the cosmos, the internet of the blockchains. So the presentation would be very brief at the end of the day, but we are trying to try to very quickly summarize without diving too much in depth into the technicalities of things, but trying to give you an overview of what we've done and what we've done it, and therefore also some historical context, some background of what happened and why we got where we are, and what kicked it off. So I start very briefly introducing myself. I'm Alessio, as Silvia already introduced me before. Thank you again. I lead engineering at Ignite. And fundamentally, our engineering team is the largest and perhaps the most skillful in the whole Cosmos ecosystem. I joined Ignite, formerly Tendermint, when the company's name was still Tendermint, back in 2018. I've been developing the Cosmos from 2018, although I actually met Jay Kwon and Ethan Bachman back in 2016. They introduced me to Tendermint Core, the research project, the product that we're building. What I do in my job is fundamentally building teams that build things and make things happen. And we are igniting a new era, hopefully, of development, innovation, trying to make all the good ideas surface and emerge and make them happen, and also helping the ecosystem to grow, continuing in a way our tradition of keeping building the cosmos, so the internet of the blockchain. So I will start right away. This is a brief agenda, so you can have an idea of what we are going to discuss today. I know very well that you have already, the audience has a knowledge of what blockchain is, so crypto, but we will kind of review it in order to explain what our journey fundamentally meant to the world, apparently, as well. So let's get started with the company. Like I explained before, the company kicked off single-handedly the whole ecosystem back in 2014, when the team was working on a consensus engine, a finite state machine replication engine that goes by the name of Tendermint Core. We have been historically the core contributor, the most important contributor, the most prominent contributor to the inter-blockchain communication protocol. We also are the people who coined the term inter-blockchain communication. And the company built the key infrastructure for what is today the Cosmos ecosystem, a beautiful ecosystem that comprises of hundreds of blockchains that can seamlessly communicate and exchange and trade and exchange data and value one with another. We believe, and we've done this because we believe the adoption comes with time. So our points must be proven, and quite fortunately, and we actually doing it. We have more than 120 people working across 38 countries. We are very decentralized, very diverse, and we're quite proud of that, to be honest with you. We believe in diversity profoundly. So that's how the journey started. I would say how the whole crypto journey started. The crypto journey started with the Bitcoin revolution. Bitcoin was a demonstration to the world that a potentially different system is viable, is possible. And Bitcoin was an experiment. Bitcoin was there to demonstrate that the financial system as we know it can actually be changed in a different way. And this concept of bringing together people and nodes and networks can actually be made possible by different consensus mechanisms. And no, there is not necessary for essential authority. People can come together and agree on a state of things. That is what fundamentally blockchain consensus is. As you know, the Bitcoin consensus mechanism is known as, it's an algorithm, it's known as Nakamoto. It's known as Nakamoto algorithm. The Nakamoto algorithm makes certain assumptions in order to provisioning security to a distributed network, to a decentralized network. There are, of course, many things. All this journey entails many things. It entails technology, so cryptography, entails design of distributed networks, but also entails economics, governance, so social consensus, and provides certain guarantees. In exchange of that, you will have certain guarantees. Perhaps the two most important guarantees are transparency and mutability. And transparency and mutability is the certainty of certain things to happen, or certain things have happened in a particular predictable way, provides business with what they need the most, the certainty. And that's why the whole premise is actually very appealing to various business sectors all over the world, as you may imagine. So you have a consensus system built and designed to allow people to exchange data, assets, value in a secure and transparent way, potentially. So, and this is Bitcoin was the demonstration that certain things was happening, it was possible to do. Our vision, and then came Ethereum. Both systems, these consensus mechanisms are based on a particular financial mechanism, which we call as proof of work. And the proof of work mechanism, the name proof of work comes with carries quite some meaning. And then we're going to dive into it a bit later. So Bitcoin, Ethereum, and then Cosmos. Cosmos is a completely different take. At Cosmos, we presented ourselves in the very beginning as the solution to Ethereum's scalability issue. As in our vision, in the vision of Jay Quants and Ethan Bachman, the two co-founders of Cosmos, there is no such a thing as a single motorway, a single public good, because it cannot scale. Technically speaking, a single network cannot scale. And that was our take. Our take was, okay, what we can do is fundamentally to decentralize a decentralized system even further. We want to take this even further. So the solution that we proposed was, rather than having just a single network on top of which you can build smart contracts, we can have actually multiple networks, self-sovereign networks governed by their on-chain governance, their own social consensus. And this design would not only accommodate more scalable systems, but also would accommodate different governance systems. As you might imagine, as you very well know, governance is not universal. There are multiple governance and there are multiple ways to achieve different results through social consensus. So we have thought about the Cosmos, and the Cosmos is today world's largest cross-chain network. We created the Cosmos Atom, the technology behind the Cosmos Atom. Atom is the coin that fuels the Cosmos Hub, the very first network of the Cosmos ecosystem. There are some figures here. It's quite hard to keep these figures up to date because of our success, must be said, and we're very happy about it. But there are so many hubs. There is more than 133 billion worth of digital assets secured, not on Cosmos Hub, but in the whole Cosmos ecosystem. There are, at this stage, more or less 38 connected blockchains. I say more or less because it's actually more than 38. Currently in Cosmos, there are about 3-4 more chains launching every month. So this number, as you can see, is destined to grow over time. And then there is also, of course, as you might imagine, we build tools, we build infrastructure tools. And there is this nice visualizers of what we call the map of zones. The map of zones gives you a view on what is going on in the cosmos. All these lines are connections between a chain and another. And that is because of the ABC protocol that we're going to dig into a little bit later. So let's get back to the proof of work system. How do we get here? So proof of work. A proof of work is all these consensus algorithms that go by the name of proof of work, the family, the classification of these algorithms. They are based on the assumption that a network participant, in order to incentivize network participants to provide security to a distributed network, the network participant needs to be rewarded, and it is rewarded by presenting the proof of a work that they have done. So the work is fundamentally generating a hash, so a mathematical problem. And in order to solve this mathematical problem, you can solve it only by brute forcing the algorithm. And by doing so, you participate to the network security. How? By fundamentally deploying capital. That's what you do. Because in order to participate to Bitcoin mining, to get the rewards, you need to buy hardware. You need to buy specialized GPUs, a specialized chipset. This amount of capital is fundamentally financial ecosystem. You put your, to some extent, skin in the game. You take some risk in order to reap some rewards. Now, this is proof of work. So you use capital in a particular way. You buy hardware to secure the network, to participate in network security. What we proposed was a proof of stake mechanism. Proof of stake is different than proof of work, as you might imagine. So you don't have to do work to participate in network security. You are not incentivized by rewards earned by providing work. Now, proof of stake still entails capital put at risk in order to provide security. In order to lend the security to the network, you reap rewards. But you don't have to do work. You don't have to buy expensive hardware. You don't have to burn energy, use energy to validate transactions and participate in network consensus. Now, proof of stake was born back in 2014. I think the very first conversations sprang back in 2012. The very first generation of proof of stake was a very small concept based on the idea that by holding assets in your hand, you are taking risk. And that idea was incomplete. It was a good incipit to what then came afterwards. But that's not enough. Just holding an asset is not enough to say that you're taking a risk. Why? Well, because if your asset is liquid, you can still sell off your asset. And by selling off your asset, you put the network security at risk. So the follow-up concept was we need to incentivize good behavior. We need to incentivize people taking risk. But how can we ensure that people don't just withdraw from the system right away? And there came delegated proof of stake. Delegated proof of stake entails the participants to the network, validators or delegators, that doesn't really matter, although there is a difference. I'm going to dive into that. They put capital risk by locking capital for a number of days or weeks. Therefore, the capital is at risk, it's not liquid, so they cannot withdraw the capital right away. By doing so, they earn a reward. Now, as you might imagine, there is no work involved. And this means an important thing, that we're shifting the balance here. We're shifting the balance from those who buy energy and hardware, from those who are just keen to take risk and put the promise at stake that they will behave. What it means behave. Fundamentally, they will not behave in a so-called Byzantine way. The term Byzantine comes from the underlying Byzantine fault tolerance. The Byzantine fault tolerant algorithm is implemented in Tendermint core and provides truly the low-level consensus mechanism through which we can identify, the network can identify the so-called Byzantine actors. So actors, they can carry out certain attacks for their self-interest. What is a potentially an attack? Well, if you think about double spending attack, that's only one of them. Or there might be a civil attack, or there might be a fork, a malicious fork. Now, the two financial economical mechanisms, security mechanisms, proof of work and proof of stake, they have different measures and there are different problems as well, because some problems that proof of stake mechanism faces is not necessarily faced by proof of work network. So again, here comes in help the immutability, the transparency of the mechanisms. By being two different economical systems, there are different ways the system can actually be gamed, or somebody can actually try to game the system. How does proof of work works, for instance? Proof of work is a very decentralized system, does not rely on the leader of the round. The proof of work means we share a ledger. There is a business logic, there is a business rule, which might go like, I cannot make a transfer bigger than my available amount in my wallet. So if I have 1,000 coins available, I cannot transfer more than 1,001. So the network will reject that. But what if an attacker actually tries to inject into the ledger a transaction would break the business logic? Well, the protection of proof of work is the verification system. Other miners will come, verify the transaction and the block. And if the block is not valid, the block is rejected and reverted. And of course, there is also the longest chain rule, and there are various mechanisms proof of work, but this entails the verification mechanism. And that's why, for instance, proof of work systems tend to be quite slow in executing transactions. Surely the difference between a proof of work system and a proof of stake system, one of the most prominent ones, is execution, it's fast execution. In order to verify that the block is valid by the business logic, by the business rule, well, the block has to be verified, and that takes time. And of course, proof of work like Bitcoin, Ethereum, they're very large networks because they're designed to be as large as possible. But that takes time. That's why, for instance, in Bitcoin, in order to execute a transaction, it might take you at the very least 12 minutes to have a so-called probabilistic finality. So to some degree, the certainty that your transaction will not be reverted in time. This works completely differently in a proof of stake system, especially in Cosmos. In Cosmos, the networks are secured by a Byzantine fault tolerant algorithm. Byzantine fault tolerance was an algorithm and subject introduced 50, 60 years ago. It was an American research funded by the Army. I think it was the Air Force. And the problem they were trying to solve was, how can we design a reliable system made of unreliable components. And then came all the Byzantine fault tolerance and the Byzantine generals problem. I leave this to the audience as an exercise to dig into it. It's a very interesting problem. Tendermint core is fundamentally a practical Byzantine fault tolerant implementation. So you have a leader of the round which proposes transactions and blocks. The others can just verify, approve, and verify. Then there is a commit. This allows us to have these proof of stake networks. So we build fundamentally a proof of stake layer on top of a purely mathematical consensus algorithm. This allows us also to scale. And there it comes IBC. IBC is given the property of Tendermint core and the proof of stake mechanism, which is called absolute finality and economic finality. We are able to guarantee, any Cosmos chain is able to guarantee that for something happen on the chain, there is a mathematical proof that can say cryptographic proof that can serve as a guarantee that something really happened. And these proofs can actually be exchanged by this protocol called IBC through different chains. And they can execute various trades, cross-chain trades. As you might imagine, in a proof of stake network, since you don't have to burn energy, you don't have to buy hardware, you can actually implement the system in a very environmental way. The crypto economics of proof of stakes, in fact, are very advantageous because you don't have to burn energy. Validating for a network is actually far cheaper than mining for a proof of work network. And there are many figures out there. I didn't want to fill up this presentation with boring numbers, but you don't have to do that work in order to lend the security to a network. Scalability, horizontal scalability is doable by fundamentally allowing more networks to spin up and connect with others. That's what fundamentally Cosmos is. And I'm going to, I don't know whether Silvia, Vale, should I give people some time now for questions and answers, or?
Well, it's up to you. I mean, are there any questions, or you can type them in the chat?
Maybe we can collect questions.
Yes.
While I can give the floor to Denis.
That's right. Yeah.
Okay.
Yes, please. Yes.
So one of the tools that we developed, that Denis and his team developed for the time, was aiming at making easier for developers and entrepreneurs to build Cosmos-based networks. And this tool is Starport CLI. Among the others, Starport CLI is truly our gem, our most powerful weapon to allow people to build more chains, to run more business on top of self-sovereign blockchains. And I leave it with you, Denis. Thank you. You have the floor.
Thanks so much, Alessio. Hey everyone, my name is Denis, and I'm gonna be talking about Starport and actually demoing it. So let me share my screen. Okay, so you should be able to see my screen now. So Starport CLI is a tool for building blockchains, for connecting them. Basically, it's a power tool for anyone to be able to build on top of the to participate, to build and participate in building the internet of blockchains. So it's a primarily CLI tool, but it has a user interface as well. And if you go to starport.com, you will see Build Now button. If you click that, you will see a command that you can paste into your terminal and install the CLI tool. I have Starport already installed, but once you run this command, you will have a Starport binary on your machine. So let's create a chain. That's basically something that you would want to do when you just starting using Starport. So Starport scaffold chain, and let's call this chain my chain. And what this will do is Starport will essentially take the template and output it into a directory. It will also add a view application. So I'm going to talk about it in a bit. It's a web template to get people started building their client-side apps for their blockchain. It also compiles everything. So with just a single command, you can get a complete blockchain. Let's open and see what we got. So let's close that. So what we got is a directory tree with source code. And the X directory is a directory for modules. By default, we give you a module that is named as same as the blockchain itself. So with just a single command, you get all the source code. What can you do next? Well, there are many things. First thing you probably want to do is start your chain locally. So you type Starport chain serve. And what this will do is it will install the dependencies. It will build proto files. So protocol buffer files is something we use under the hood to describe data structures and the API and pretty much everything. So it compiles proto files into Go. The blockchain is written in Go. Under the hood, Starport, of course, uses Cosmos SDK. So if you go into the X directory in my chain, you'll see a bunch of Go files, and they are using Cosmos SDK as a framework for the blockchain itself, right? So this is not a client. This is not a smart contract. This is actually a sovereign, independent blockchain, similar to Cosmos Hub or Osmosis, Stargaze, or any other blockchain in the Cosmos ecosystem. By default, it doesn't have much under the hood, mostly standard modules, but you can, of course, change that, and I'm going to show it right now. So with one command, you get a blockchain running locally. So it initialized the node, it created users, and it started the API and even a faucet. So what we can do next is we can scaffold more modules. So Cosmos SDK is a modular framework, so it makes sense for a developer to kind of have separate functionality into different modules, right? So let's say we're building a DEX, so a decentralized exchange. So what you would want to do is probably scaffold a module called DEX, and this will create a new directory in the DEX. It will also change the app.go, and in proto files, it will create a new directory with a DEX. So let's wait for that to finish. So in the meantime, we can view the config file. So every blockchain created with Starport has a config file, and you can set all the properties here. For example, you can add accounts. By default, we just have Alice and Bob with tokens, but you can change the behavior of Starport as well as configure the blockchain itself. So now that we've created a module called DEX, by default, it's empty. You can see that the main file that handles messages is pretty much just a switch statement, doesn't have much inside. But what we can do is we can add more logic to it. So let's say we scaffold a list. Since we're building a decentralized exchange, we're going to have a list of pools, right? So let's say list. We want a list of pools, and each pool will have amount, and amount will be in type coins, and it will have a denom that is going to be a string, and let's say there's a property called height, right? And height is going to be an integer. And we want to scaffold that in a module, of course, dex. So what the list command does, scaffold list, is it creates a CRUD, so create, read, update, delete, for a particular model. In this case, it's a pool. And we provide the fields that we want this model to have, right? So we want the pool to have an amount, and we know that it's going to be of type coins. So this allows a developer to quickly prototype their application and create all the boilerplate code, all the templating out of the box, right? So you don't need to type anything. You just run one command to create a model, and then you go and modify individual files to implement the logic. So we can see inside the dex, inside the handler, we now have create pool, update pool, delete pool. So we have all the CRUD logic to operate with pools. And of course, the logic is in the keeper and so on. I'm not going to go through all of this right now, but what we can do right now is we can, again, start the chain, and let's see how it works. So while this is running, let's wait actually for it to finish before we continue. So it will set up a node using this config file, as I mentioned previously. Right now, it's only one validator in development. We support only one validator, but we're going to change that hopefully in the near future. Of course, the blockchain can have in production as many validators as it needs, right? But in development, it's actually easier to have just one because it's faster, and anything that runs on one validator will likely run on dozens or hundreds of validators. For developing purposes, it's actually easier. So once Starport is done building, we'll open a new terminal and actually try using it. So our blockchain is called MyChain, and Starport has built chains binary, which is called MyChainD. And you can see all the commands that it has by default, but what we're interested in is commands for the DEX module. So if we type that, we will see create pool, delete pool, and update pool. Okay, so let's create a pool. So we can type create pool, and we know that it accepts an amount, denom, and height. Amount is a list of coins, so we know that Alice has tokens and stake. Those are two tokens existing on this blockchain. So let's say this pool is going to be 1 token and 5 stake, just for example. And the denom is going to be stake, and height is going to be 8. Of course, this is just an example. It didn't scaffold the DEX, right? It created the skeleton for a model called pool. It doesn't know the logic, but it knows how to create one. So let's do that and run from Alice, so that we need to pass a key that is used to sign this transaction. So we can see the transaction. Desk says if you want to sign it, we say yes. And what this did is, what we did just now is we used the binary of the chain with the scaffolded command to create pools, and we broadcasted the transaction to our blockchain running locally. And now we can use the same binary to see a list. So we do query dex and list pool, and we can see that our pool has been created, and it has all the data that we broadcasted. Also added a creator, which is Alice's address. We can also verify that here. You see Alice's address because we used Alice's key to sign this transaction. And we can create more, and it will just populate this list of pools. Of course, now, like once you have this skeleton, you can imagine you can run more scaffolding commands, and then you can go into message server pool and actually change what create pool means, right? Maybe you want to change some logic here. Most likely you want to do that. Maybe you want to completely remove update pools so people can't update pools or delete, etc. Right? So you can go directly into the code. You have everything here. You can create, of course, more models. You can create more modules. So this is very flexible. And yeah, that's about scaffolding. Now, of course, Starport has more features than that. Let's take a look. So Starport has functionality to scaffold logic, chain commands to run, build the chain. It can generate clients for with TypeScript and Dart. It has an IBC relayer, so we have a set of tutorials. If you go to the documentation that we have, you will see a list of tutorials, and one of them is a tutorial about IBC. So throughout this tutorial, what you're doing is you're creating two blockchains, and you're creating a connection between them with IBC, and you're sending packets back and forth. It's a very short tutorial. You can complete it in like 1 hour, but it gives you an understanding of the basics of IBC and how you can build an IBC-enabled module. One more thing I wanted to show is that it's not all about the blockchain code, right? That's a very important part of Starport, right? And scaffolding is mostly about blockchain, right? So we support many different things that you can scaffold. This is just one of them. But from the very beginning, we kind of realized that a blockchain code is just a part of the story, right? It's probably the most important part, but it's just one piece, right? And another piece is enabling developers to build clients, right? Because when you build a new blockchain, most likely you want users to be able to use it, right? You want a web application, for example. So alongside the blockchain code, we also scaffold a template, and I'm gonna quickly demo that as well. So inside the view directory, we have the source code for a client-side Vue.js based application, and when I run it, it will open a very kind of basic template that you can use to build your own application. So I have Kepler already installed. Kepler it's an extension that is used by Cosmos blockchains to store private keys, right? So it's a wallet, it stores the key, and I have an account here, called him Frank, and Frank has an address, so let's add Frank's address into the config file. Let's copy Bob and use Frank's address. Instead of Bob, it's going to be Frank. Frank will have address. That will save, and you can see Starport automatically resets the state and rebuilds everything because one of the files was changed, right? So config file was changed. If we modified a file with the source code, it would also reset the blockchain and rebuild everything. And this was done so that we kind of simplified the developer flow, right? So you don't need to reset your chain manually. It rebuilds. Right now it's pretty slow, but we're working on improving it. Our philosophy is make it work, make it right, and then make it fast. So we're at make it right stage right now. It's still easier than running shell script, and it's definitely more reliable. So let's wait for that to finish. In the meantime, let's run the web app again. So we now have 3 accounts, and one is Frank. So if we go back to our web application and connect our wallet, right? We have a wallet installed in our browser and we can connect it. We'll approve, and now we can see Frank's balance in the asset list, and we can use send and receive tokens. So let's send some tokens to Alice. And to stake, we approve the transaction, and we see that Frank has fewer tokens now, and one transaction was created. So this is just a very basic wallet, but you can see how you can take this template and improve it further, right? So it's a very simple template. You can just take that and build your own application out of it. And one probably last thing I'm going to show is inside the data page. It's actually empty, but if you go into the source code and uncomment one of the components, provide the path to your modules. It's Cosmos, MyChain, DEX, and item name is pool. So this is just a pre-built component. You customize the store name and the item name. You save it, and now you have pool items. So what we can do is we can, again, create the pool like we did previously. So let's say list of pools. I mean, it was reset, so so we need to kind of recreate the pool again. So MyChain D, TX DEX, create pool, 1 token to stake, foobar, then 5 from Alice. So again, we're creating a pool because we reset the blockchain and the state was deleted. So now we can immediately see it here, right? So we created a pool in the CLI, and we can see it in the front end. We can do the same thing here. Just gonna do 1, 2, 3, 1, 2, 3, 1, 2, 3. Kepler opens a window to broadcast a transaction. Ignore the amount because we didn't provide it in a proper format, but you can see 1, 2, 3, 1, 2, 3. And if we query it from the terminal, we'll see that it's working as expected. So we have both. We have 2 pools, one created from the CLI and immediately shown in the web application, and one created in the web application, and we can see it from the terminal, right? So this allows every developer to see the whole picture and get the feedback loop very quickly. So I think you can imagine how this improves the developer experience and the whole flow of building blockchains and clients. Of course, we do much more than that. If you go to starport.com, you will see that we also have a mobile application support, so you can run Starport scaffold commands, Starport scaffold Flutter, and I'm not going to do it right now because I will need to start Xcode and a simulator, but once you do that, you will get an application that is kind of similar to the web application. You can customize it and build the whole ecosystem around your blockchain, essentially, right? And we provide all of this out of the box. Of course, it's all open source, so you can go to GitHub, /Starport, and contribute to it. It's all open source and very active. And you can even run Starport in the browser. So if you don't want to install it for now, you can just click on this button, Build a Blockchain Web-Based IDE. It will open a Gitpod editor, and you will have Starport in your browser, so you don't even have to install anything. It's the same exact binary, and you can build a blockchain online. You can open 2 Gitpods and connect them through IBC. So it's really cool. You can experiment and do all sorts of things with this. So yeah, please visit starport.com, explore our tooling, provide feedback, join our Discord if you have any questions. It's very active. We're answering all the questions there. And yeah, I guess that's it. Thanks so much.
Thank you, Denis. Thank you, Alessio. Now, I was wondering if you have any questions from the audience. Ian?
Hi, Denis. That was a great demonstration. Very brave of you, because I know how these things always fail. And so it was good to see it working. I'm really impressed with it. So I teach blockchain development, and we use other blockchain development environments. But I'm really impressed with that, and especially the last point you made about creating it all in the browser. That would be really useful to some of our students. The one thing that, of course, I have to raise is, and you did raise it yourself, but obviously you don't have enough time, is can we still write the smart contracts within that in a test environment? One of the things that we do with other blockchains is write smart contracts. That would be like the icing on the cake. I mean, considering how fast it is to get up and go, is there opportunities to do that as we get more advanced into doing blockchain?
That's a really good question. So basically, smart contracts is just one paradigm of blockchain development. Cosmos SDK is built to create blockchains as complete applications. They're modular, but they're written in Go. So it's a different paradigm. I like to think of this is like there are browsers and there's JavaScript within browsers. So browsers are applications, and that's what Cosmos SDK is for, right? It allows you to build a browser, and you can do anything there. You can also build an Excel, but like a spreadsheet thing, or I don't know, a program for painting, any kind of application, right? Whereas smart contracts is scripting. So by default, we're advocating for building blockchains in Go using Cosmos SDK and writing these modules. And we're building all the tooling for that because we think this is a very great way of building blockchains. But if you want to enable your blockchain users to add logic to your blockchain, like you built a DEX with Cosmos SDK, for example, but then you want to add scripting to your blockchain, you can do that. We have a module called CosmWasm, and it lets your users write contracts in Rust. So it's kind of an alternative way of building logic on your blockchain. So I recommend trying both and like going through tutorials first to see maybe like writing modules in Go is the way you would prefer to write blockchains. But of course, if you want to add smart contract support, that's also possible. And there is also a module that implements an EVM machine on top of Cosmos SDK, and you can write smart contracts in Solidity.
I can actually pitch in also. Yeah, there is another thing. Cosmos SDK was when we built Cosmos SDK, that was meant to be just a tool set. So a blockchain application built on Tendermint core is fundamentally a final state machine. That's what it is. Cosmos SDK is just a set of tools that makes your life easier. And Cosmos SDK is a proof of stake layer. But that doesn't really put on you the obligation to use proof of stake. So you can even prove, there are many use cases where you want a proof of authority, or you want to customize the proof of stake. Maybe there are some use cases where you can't really give people rewards for a number of reasons. So Cosmos was in the beginning thought and designed to be, I would say, smart contracts free. But of course, the demand for smart contracts came along the way. And like Denis said before, there are now at the very least, a couple of technologies that allows you to build a smart contracts on top of any Cosmos SDK network. One in WebAssembly, WASM, which is very popular currently, because with WASM, you can build a run executable in this. and there is no problem whatsoever. And that is Cosmosm. And then there is also a software called Evmos. I think it's, I don't know whether it's still Evermind or Evmos. Fundamentally allows you to run Ethereum virtual machine on a proof of stake powered network powered by Tendermint Core, Cosmos DK Tendermint Core. Starport CLI gives you the possibility to pick your menu and assemble components the way you want.
Okay.
Thank you. Yeah, that's the kind of answer I was expecting in a way, because many of the other blockchains are like that. I mean, I'm definitely interested in teaching this to our students and taking this on board. The fact that it runs in Linux and everything else is just really suited for us. If we have any questions, so if I'm delivering something, I mean, what is there? I know you've said that you've got GitHub up there where we can query it. But if you could, I know that last bit you showed us, Denis, where you just went from the website to the in-browser, so the cloud-based tool that you've got. Could you just show me that again? Because I missed that link. So, and that, yeah, I'll let other people ask questions then. Otherwise, I'll dominate everything.
Yeah, absolutely. Let me share my screen again. If you go to github.com/Starport and you scroll down, you will see a link, build a blockchain with Starport using stable version or a nightly version. You click that, it will prompt you to sign in with GitHub, and it will open an editor, right? I'll also paste the link in chat so it's easier for you, but yeah, you don't have to install anything. It actually works from an iPad as well.
Yeah. Okay, that's fantastic. Thank you for that, because that's a really good tool. Because half the problem in teaching blockchain is setting up the environment. Now, if you've already got that environment set up, it's a game changer for our students, especially. So that's really good. Thank you.
In our experience, we delivered the demo to the University of Malta a couple of years ago. There was 2-3 days of work, and the students were so happy because at the end of the 2 days or 3-day journey, so I built a blockchain. And it was, you truly did. You have a consensus engine, you can actually spin up nodes very quickly from your terminal, and you can run transactions and commands. And so yeah, people tend to love the ease of use of the old platform.
Right. I have a question. It's more or less a follow-up on Ian's question about simulation for our students, because we have an applied computational finance module, and we might try to build some finance-related blockchains. But can we try? I mean, we can code in any, in Go or R, even R. You can write a blockchain in R. But if we want to simulate an actual blockchain, can we use Cosmos to do that? A simulation, not real, but with the view of doing it for real, actually. That's for Denis, the question. Yeah.
Oh, okay. Well, you can start. So once you've written the source code,
yep.
You compile it, and you can start a local test net. You can distribute this binary and start a network on multiple machines. This is actually something we're looking into streamlining coming soon, but soon is going to be much easier to do that. But right now, of course, you can do it manually. It's pretty straightforward.
Okay. All right. Using Starport.
You're using Starport to scaffold the code, to kind of build everything.
Yeah.
It's a development environment, but once you go into production, you're just using the binary itself. So the blockchain is compiled into a binary, and you're using that binary.
Okay, thank you. Any other questions for Alessio or Denis? Okay, well, if there are no more questions, so thank you very much for coming here, for giving the presentation. It was really, really awesome. Oh, Akram wants to ask a question. Akram, you raise your hand. No, I don't know. Okay, all right. So I'll see you later. So thank you very much for being there. And this will be recorded, so we'll divulge it to our students. And if we have any more questions, so we'll contact you. Is that okay? Yep.
Thank you, Silvia. Thank you,
Okay.
Alberto.
Thank you, Alessio.
Thank you.
Thank you, Denis.
Yeah,
Okay.
nice to
Thank
meet
you.
you.
Thank you, Denis. Goodbye.
All right. Bye-bye. Bye, everyone. Bye.
Yeah, goodbye.